Okay, good night. My name is Juan Jose Peña Santos, and in this moment, I speak of the basic concepts of the hydraulic in the life and in the channels. My group is conformed of the Carlos Andres Lopez and Diego Sebastián Benavides, and my person, Juan Jose Peña Santos. The first is the introduction.
Okay, closed structure are now the closed conduct, and those which open toe are called canals. Expression are the derived for the energy and the monument coefficient, the accounts for velocity distributed on channel section. Continue. Definitions. The channels are open or closed conduit in which the water circles due the action of gravity, and know the pressures, science-free surface, and the liquid in contact with atmosphere. This means that water flow derive atmospheric pressure and in the own ways. Continue. We can free surface fluid in the heap times later due lager inflows produced in the sudden storm. The severe may flow full and the pressures. Continue. Classification of flows. The classification is on the upstream and downstream. In this image, we see how the flow changes depending on the water upstream is low flow and change to pressurity flow is negative. And in upstream, in pressurized flow and low is positive. Continues.
Hello, teacher. The zero fluid, the velocity of the element varies in magnitude and the direction along its flow line. If each element passing through a given point follows the same the same flow line as the preceding elements, the flow is said to be steady of stationary. Flow may start out non-stationary and become stationary over time. In a stationary flow, the velocity at each point in space remains constant over time. Also, the velocity of the particle may change as it moves from one point in space to another. A particle may change as it moves from one point to another. Continue, please. The the unstable fluid stable regime flow is understood as when each point of the fluid, the velocity remains constant over time, so that each particle passing through that point will have that velocity, and otherwise the flow is a unstable regime. Continue, please. The non-uniform flows in this part of the flow in which the velocity vector is not constant along its extremely and occurs in water courses or brine curves sections or slopes. Continue. So in this part, we have the laminar flows and the turbulent flows. In the laminar flow is where the air moves in the same volume and in the same direction through the clean room or a controlled environment zone in a parallel flow with uniform velocity. And the other, the laminar flow, is where the air moves in the same volume and in the same direction. So the clean room or a controlled environment zone in a parallel flow with uniform velocity. So in this part, we have the form that is the Reynolds number is equal to the mean flow velocity multiplied for and characteristic length, and all of it is divided to the kinematic viscosity of the liquid. Continue.
Okay, in this moment, explain up the types of the fluids, the flows. It's considering three types: subcritical, supercritical, and critical flows. This considering in this considering is of the number of the flow number. The flow number is the number of the classificate the flows in the hydraulic. The with fraud is less than 1 is considered a flow supercritical. The flow is more than 1. Fraud is more than 1, it's supercritical. Fraud is less than 1, it's subcritical, and flow is equal 1, it's considered critical. The fluid, the number fraud, the fraud number is form with principal, it is basic the velocity and gravity and the height of the type of the square. Then the velocity is too much high, the flow it's more, and the velocity it's less, the flow is less. It is directal of the velocity. Velocity distribution. The flow velocity is change selection varies from point to another. These two stress at the bottom and at the side of the channel, and the option to present free surface. In this part, consider of the velocity, it's different points of the channels. For example, in the triangular channel, the velocity in the center of its the double of the velocity in the lateral triangle. In the trapezoidal channel, the velocity it's double of the velocity in the base of the channel. And in this moment, in this part, most of the different velocities in different part, because for example, in the natural irregulation channel, what is the channel of osmosis presented in the natural is the most rate of the in the base is its main is less velocity, and in the superior part the velocity is too much high. In this part, most the graphic of the velocity and different to high, and in this part most this too much high, the velocity is curved to high. In the energy coefficient, most two equations, but it's too much similar, and because it's different. The equation one represent the velocity had in the channel section, but in the second equation, most of the velocity head and the velocity head in the part. The different may be taken into consideration the introduction and energy coefficient. Thank you.